Hello, I'm Alyssa, and this is our Dynamics Project 2, and I worked on it with Juan and Esme. In this project, two blocks with different masses hung on a pulley system were analyzed to calculate the speed of both masses at a time of 1 second from rest and the speed of both masses after one move down 1 meter after the system was released from rest.
Our diagram consists of a pulley system with block A having a mass of 25 for me, at 35 for Alyssa, and 20 and 45 for Esme. As for our block B, I had 20 kilograms for me, 30 for Alyssa, and 40 for Esme. Our free body diagram consists of A having 1 tension and B having 4 tension. As for my calculations, I had a mass of 25 and a mass of 20, which I converted into 245.25 for A and 196 for B. Then I solved for SB plus SA equals L, which gave me 4B equals negative 1/4 of VA, which then I plugged into the impulse formula, which gave me minus 196.2 newtons times 1 second minus 0 seconds plus 4 tension times 1 second minus 0 seconds, which equal to 25 times negative VA over 4, which I use the same process for the second part of my equation to give me 0 minus 245.5 newtons times 1 second minus 0 seconds plus tension times 1 second minus 0 seconds, which gave me 20 times VA, 20 times VA. Then which I solved for tension, which gave me, and that concludes my calculations.
For my problem, I was given a mass of 35 kilograms for block A and 30 kilograms for block B. I solved for their weights by multiplying 9.81 meters per second squared to the mass. In the first part, I solved for the speed of both masses at 1 second. Using the impulse formula, I was able to solve for VA2 by plugging in T equals 35 VA2 plus 343.35, which gave me 7.32 meters per second downward. I then plugged the calculated VA2 into VB equals negative 1/4 VA, which gave me VB2 of 1.83 meters per second upward. In the second part, the diagrams remain the same, and I calculated for the speed of both masses after one move down 1 meter. I first solved for the change in length, which gave me delta SB equals negative 0.25 meters. I began using the T1 plus U minus 1 minus 2 equals T2 equation to find VB2. But in order to find VB2, I needed to find VA, which I solved and got negative 4 VB. I then was able to plug in negative 4 VB to find VB2, which was 0.956 meters per second upward. Then I was able to plug in and find VA2, which was 3.82 V downward.
Okay, today on my calculations, I'll be talking about from my perspective of our project. My mass A was 45 kilograms and my mass B was 40 kilograms. First of the velocity is the derivative of the position. I did initially at rest and solved for the reaction of the relation from mass A to mass B. Reminder, it is attached to the ceiling, so we did not have to track their distances of the rope or string. In my diagram, I had mass B had 4 ropes that were dependent on the system, whereas A only had 1. The length of the rope in my case was calculated. L equals SA plus 4SB, and I also did plus a constant. Then use the time derivative and second derivative to get SB equals negative 1/4SA. Then use the sum of forces for Fy to calculate each perspective tension in the relationship. But before I get into that, note that the relationship for the acceleration was the same. So overall, as a summary, I got VB2 was 1.0326 meters per second, and the formula for VA2 was negative 4.1034 meters per second. Now in the motion, when we calculate it as 1 meter, I can use V equals V naught plus A acceleration times T. For A, it was 8.58 meters per second squared moving in the downward direction and 2.145 meters per second in the upward direction. This concludes my calculations. And for the summary, through these calculations, we were able to see that the speed of both masses at the time of 1 second from rest had an upward movement with block A, and there was a downward movement with block B. When the speed of both masses after one moved down 1 meter after the system was released from rest, block A had a downward movement while block B had an upward movement. Thank you.